Okay, here's warm-up 6.5. We're going to graph this exponential function. Okay, it says include the y-intercept and the horizontal asymptote. All right, so a horizontal asymptote it's a horizontal line that my curve is going to approach. Okay, and that is going to come from whatever is added or subtracted to the end of the equation. So my horizontal asymptote here is it has to be the line y equals something to make it a horizontal line. And here it's going to be y equals 1. Okay. So here's what y equals 1 looks like. That's my horizontal asymptote. Okay, usually I would find the x and y intercepts from there to graph this, but this is not going to have an x-intercept because everything's going to be happening above the horizontal asymptote. It's never going to cross the x-axis. Okay, so let's find the y-intercept. So to find the y-intercept, I'm going to plug in 0 for x. So I didn't use function notation, but I could have here. Okay, so I plugged in 0 for x, and 2 to the 0th equals 1. And then following PEMDAS, I do the multiplication next, which so I get 3 plus 1 is 4. So that means that my y-intercept is 4. So my graph is going to cross the y-axis at that point. Okay. And now I have to know if this is going to be exponential growth or decay. So that's all has to do with the base. So if the base is a number more than 1, that means I'm going to have growth. And that means I'm going to get a curve that goes uphill. Okay? So I know it's going to approach this line as it goes to the left, and I know it's going to cross the y-axis there. Okay? You could find some other points if you wanted to, just by, say, plugging in -1 for x, or plugging +1 or 2 for x, or whatever. But I'm just going to go based on the fact that I've got this information that I've already graphed, and I know the basic shape. So it's going to go something like that. And there we go. Okay. All right, so now let's find the equation for the inverse. So I'm going to take the original function and switch the x and the y. Okay, so f of x is our surrogate y there. So switch the x and the y, and now I'm going to solve this for y. So I'm trying to isolate y as much as I can with just algebra, with old school algebra techniques. So I can subtract 1 from both sides. Okay, and then I can divide the whole equation by 3. And now I've got x minus 1 over 3 equals 2 to the y. All right? And at this point, we would have to put this in log form to isolate that exponent. Okay? So let's see. Log form, my base is 2. The y is going to get isolated, so that's going to be over here. And the fraction is going to be the contents of the log, or the argument. Okay, so it's going to look like this, and then not a bad idea to put it back into function notation. Okay. All right, so there's our equation. So we've got a log form, and now on the next part, we're going to graph this log. Now this log is a little weird to graph because we've got a fraction in the as the argument. But what we can do, if you remember that when you graph the inverse of a function, it's going to be the same as reflecting over the line y equals x. So if I imagine what this would look reflected over this line, I'm going to have a curve somewhere down here. But also the asymptote, instead of a horizontal asymptote, I'm going to get a vertical asymptote. So instead of the line y equals 1 for my horizontal asymptote, I'm going to have a line x equals 1 for my vertical asymptote. Okay, so yeah, this would be my vertical asymptote. All log functions are going to have a vertical asymptote when you graph them, and then exponential ones will always have a horizontal asymptote. That's good to just memorize. Okay. All right, so what I'm going to do also is take this point that I knew from the first problem, this was 0, 4, and when you reflect over the line y equals x, you can just reverse the xy pair. So that means 4, 0 should be on the inverse. So there's 4, 0. Okay, so now I got some good information here, and I'm well on my way to graphing this. And so, you know, there's going to be a curve somewhere down here. Now I have some guides for drawing that curve. Another thing I like to do is look at the base. So I still have a base when I'm in log form, and if the base is more than 1, I still think of that as a growth curve. So that means it's going uphill. Yeah, it's going to curve kind of like this, but it's still going uphill from left to right. As opposed, if I had something like 1/2 or a number less than 1, then it'd be going downhill. Because you could draw a curve like that or a curve like that. But since that base is more than 1, I know it's going to be an uphill curve, something like that. And again, you could plug in some other x values to get some more ordered pairs if you wanted to, but it's going to look something like that. Okay? All right, that's the end of the warm-up. See you next time.